ionization. Ionization is almost like dissociation, but we talk about a dissociation, they're just dissociating from each other. They're the same, ion, 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 ion. Nothing's really changed, they're just separating, right? For ionization, they have to create the ions. These are two nonmetals. Two nonmetals and a bond is not an ionic bond, it's a two nonmetals? What kind of bond? Your term is next week. What kind of bond? Covalent bond, which is a shared pair of electrons, right? So here you have H, they're sharing their electrons with I. I think you guys need to do a bit of work on the weekend about preparing for your midterm. So here's a shared pair of electrons. This is how HI exists. Okay? In order to ionize it, so if you guys were just sat beside each other and talking too much, right now I'd be like, separate. And you could go over here and you could go over here. Funny how I pointed to you two. And you're none the wiser. You just take all your stuff and you just take all your stuff and you're still you and you're still you and there's no big deal. Okay? This is like you're writing an essay together. And I say, you've shared this essay, but you're too talkative. You separate and you have to write your own essays now. Okay? Now somebody is the bully, has more affinity for these electrons, and is going to take the entire part of the essay with them, leaving the other guy with nothing. So who has more affinity for these electrons? What's your gut instinct without even looking it up? Iodine. So I takes all those electrons and leaves H with nothing, making this become H positively charged, and I, X, 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 gain an electron, overall negatively charged. You see that? So it's different in its theory because I'm not just separating these two ions, but rather I am creating these ions and saying, hey, you shared a pair of electrons, you got to get over there. But that's if I were to draw the dot and cross diagram for it, which would be a really good midterm question because it combines your understanding of solutions and it combines with your dot and cross diagrams. Do you see that? But if I'm just asking for an ionization equation just by itself, I actually don't need the dots and crosses. I didn't do the dots and crosses on my dissociation, right? I just put Cl minus. I didn't put all the dots around it. So actually, the ionization equation is just Hi becomes H plus and I minus, aqueous, aqueous. And this says, according to that it's a gas. So I actually haven't done anything different between question 2 and question 1. Do you see that? That this is exactly what you would have done in question 1. Everybody understand that? Except for the differences in the theory. If I ask you for the theory behind it, I have created ions because they were sharing. Whereas in the other one, they weren't sharing. They were already ions. I just told them to move apart. Have you drawn the dot and cross diagrams in your book? But you're going to now. Oh, okay. All right. And then this is actually the ionization equation. So quickly do this one. Quick, quick, quick. I'll do it on the board. While you're doing it, heads down, you do it. Eyes up, I'll do it. And then class will be over for today. Is that what you put?
Yeah.
Simple, straightforward, just like it was yesterday. Or question 1. Make sense? Xander? Make sense? Okay. All right.